The first priority was to find the best possible way of reaching the aircraft. At a depth of 750 feet, it was a factor that needed serious consideration. Using the latest in computer technology, the options were slowly narrowed down. Several expert underwater salvage companies were approached. In the end, Dakon Subsea of Norway was chosen. An underwater remote-operated vehicle was to be used for the mission. Equipped with a front-mounted camera and rubber tank treads, it was capable of diving and crawling along the bottom. But how would they lift the plane? In Norway, Dag Amerud, chief diver and team leader, along with Gunnar Gunderson of Dakon Subsea, devised a plan for the rescue. Using a series of precise calculations, the team creates a collection of innovative ideas for the project.
So, Doug, here's our ROV, and can you tell me about this is the treads you're talking about? That
yes.
You can move across the flat surface of the wing?
Yes. And that is very special about this ROV.
Yes.
It's not an ROV, but it's a sea ROV. It's crawling.
Ah, okay. Yeah.
It's crawling.
Yeah. Okay. And what kind of depth could you work to with it? What's the maximum depth you could work to if you really had to?
800 meters.
Wow, 2,400 feet.
Yes. And what's special for this operation is the cable drum, or the wire drum on top.
This wire drum?
Yes.
And it's what will you do with this? How will this work?
When we have something to pick up, we grab it with a special claw, lock the claw, and release it.
How does it lock?
It's locking with this special kind of actuator. It's completely locked when it's locked. It's not possible to open it.
Is it like a vice grip?
But it's okay. You can call it a kind of a vice grip.
Yes.
And we release it from the sub, and we have the wire on this drum, and we go to surface with the ROV, pick up the wire, put it onto our winch, and then we start lifting.
Ah, so you lock on and string out your cable to the surface.
Yep.
Using this.
Yes.
And then you're able to retrieve the item that we need.
Yes.
Ah, good.
Using the underwater ROV camera, this fascinating descent into the depths of Lake Mjøsa is captured on videotape. Finally, there it was, what they'd been searching for so long. Halifax NA337.
The plane is not laying horizontally. It's not possible to start to lift in a wire with an ordinary lifting wire because all the weight will be on that special wire, and the other one will pick up later, and that's too late because the wire will break.
Yes.
You are not able to get an equal lift on every wires.
Mm.
Therefore, we had to look into a system that would take care of the forces at the same time, and on this place or an area of the plane which was very solid, and that was the frame in the wing. And the wing itself is a very strong construction, so that was the place that we had to put our lifting.
Sure. So I know that we have the two main spars. We have the forward
Yes.
main spar that runs down through here in the center section, and we have the rear main spar that's back here that runs basically parallel to it.
Yep.
And so we'll be able to lift utilizing those two main members.
Yeah. Our lifting device is gripping through in between these two engines.
Yes, the two inner engines, right?
Inner engines, and is lifting, and the point of lifting will be in the main spar.
Mm.
And we have a secondary lifting point in the aft spar, and that is the way that we will try to lift it.
Mm-hmm. Mm-hmm.
then it will, we have to control the lifting force, so we don't lift more than we expect this beam the main spar to stand for.